Hey, do you guys know what the last body part to decompose is? It's the eyes. They dilate.
Come on now, dog. Come on, man.
Hey, Stats Cats. Mr. C here. Welcome to another video. We're going to do section 3.2, I should say. Oh, we're off to a great start. Basically, I'm going to show you the design work for the guided notes for section 3.2. Again, this is Elementary Statistics 14th edition by Mario Triola. And as I say in all my videos, they don't pay me to advertise it, and also fair use, but I do want to give credit where credit is due. So yeah, the previous section was on measures of center, so basically the mean or the average. And this one, a natural follow-up to that section would be standard deviation. But the standard deviation is just one type of measurement for variation. So I make sure to hit on all the ones that are spotlighted in this section in this guided notes, and I'll go ahead and get us rolling. So as I was reading the section out of the textbook, the author opens up saying something to this effect, that variation is the single most important topic in statistics. And I thought, wow, that might not have been, what I think is the most important topic in statistics, but this he's already on his 14th edition, so I'm going to take that pretty seriously. So anyway, it is super important, and I would back that up. All right. I had ChatGPT create a little graphic for me right here. I'll zoom in on it for you guys if I can. Oops. Here we go. I basically asked ChatGPT to create a cartoon graphic of Coca-Cola boxing Special Cola, which I'll get to why I have those names in just a minute. And I thought it was straight jackin' where it says "Stay thirsty, my friend." I thought that was for Dos Equis. But anyway, I thought the graphic was good enough and pretty funny. And the reason why I have that in here is because it relates to this histogram. If I can shrink this down. Okay, so this is from the section itself, and I thought this was a great opener for the section, so I wanted to include it in my notes as well. So here we have frequency distributions in graphical format, histograms that is, and I say, hey, check out these two histograms, and the first histogram are measurements pertaining to, well, what should be 12-ounce cans of Coke, regular Coke. And so we have the measurements for volume in ounces. And then Special Cola, all right, shout out to this meme right here. Special Cola is what we're basically comparing these measurements against. And what's really interesting about these two data sets is that they actually are going to have the same mean of 12.2 ounces. But as you can see, the histogram on the right, it looks a lot more chaotic than the histogram on the left. And so this is kind of the idea of variation. So you can see that the regular Coke histogram shows that there's a lot of consistency, and that is an extremely important topic to hit on, especially, when you're talking to your students. You might have some students that are business majors, and this would be really important, to somebody like them. Whereas the Special Cola, although the measure of center is the same as the regular Coke, as I mentioned, this is much more spread out and a little more, I guess, random, if you will. So I wanted to remark on that. It might be hard to believe, but the data sets corresponding to these histograms had the same mean. However, the amount of spread, aka variation, so spread is a good descriptor of variation, which I guess itself is a descriptor as well. But it is much different between the two. And so I figured this might be a great conversation starter between the students and I. It says, although they say variety is a spice of life, why might a large spread in data be a problem for a company manufacturing cans of soda? And think about it from both the company's and the customer's perspective. So I'll throw that out to them and just kind of field in some answers and jot them down as they come up. And I think it'd be a great conversation starter just to get them primed up for the material that's to come. So as I mentioned, there are 3 types of variation that are featured in this section, and those would be the range, standard deviation, and variance. So it starts out with the range, which is what I'm starting out with. And I have the definition. The range of a set of data values is the difference between the maximum data value and the minimum data value. And so I have a box here for the range. Now, normally I would, you've probably seen me do this before, go to insert and do text box. But what I find myself doing lately is actually inserting a table for these formula boxes. And the reason why I'm doing that is I find it a little easier to format them. So like, let me get a new document going here. Let's say I wanted to create a table of that size. I go to insert table and we'll do a 2x1, 2 rows, 1 column. And it's easier to change like the sizing with this little drag box. Also, you can change, the width of each row like so. But up here where it says table layout, I use this a lot where it says align center. And when you do that, it puts you at the center of the cell, which I know that's not a huge deal, but when you're trying to edit these things, it takes some time. So this could save some time for you guys. So with that there, I just go and select my font. As I mentioned before, I like to use Tahoma, size 10 for these little formula boxes. And I'll just put formula for the range. And then I'll go to this cell, and you can see it's not aligned like I want it to. So I'll just go back to table layout and select the middle one again. And then what I did is I hit insert equation, and I just typed in range equals. Later on, I'm going to show you, well, actually, I'll show you now. So hypothetically speaking, let's say the range involved a fraction. What you could do is you hit the fraction like so. Click that, and then if you want to make this fraction bar longer, what you can do is just hold down the space bar until it's to your satisfaction. So I figured I'd just mention that now, even though it's not, I guess, technically part of the range formula, at least the way it's presented in the textbook. All right, so I asked Claude to help me out with something that I'll present later, and it's basically going to be a set of data related to the field of facial recognition, which is very near and dear to my heart because it's a subtopic of linear algebra, which is one of my mainstay courses that I teach. Well, I guess I should mention this too. So you might know that there are some statistics that are sensitive, say, to like outliers. And due to the nature of the formula for the range, this is definitely one of those sensitive statistics. And normally I would just, jot down somewhere, note that this is a sensitive statistic, but I figured I might kind of, try something a little different. And I had ChatGPT create a little graphic for me. I started out with sensitive content. I said, can you create a simple sensitive content icon that I can include in my note packet for students? And it came up with this, which I like, but then since it's pertaining to a statistic, I was like, well, maybe ChatGPT can, adapt it to say like sensitive statistic. And I think it did a great job. I put, can you modify in the context of statistics? And it say sensitive statistic. And so this is what it came up with. I'm very satisfied with that. So I just downloaded it and inserted it into the notes. And I think that might be something that I continue to do. That way it kind of saves on some space and also makes the notes a little more visually appealing. So yep, there's that. So this data set we're going to see again later, but it's 9 data set values, and you don't really need a whole lot of space to work out this example. One thing you do want to make students aware of is that in practice, it's a good idea to order these from least to greatest. So, just kind of allocate some space towards that. The next of the trifecta of variations is the standard deviation. And there's some symbolism, as you might be aware of, specific symbolism pertaining to a sample and also one containing to a population. And we're going to fill that out together. And standard deviation is a measure of how much data values deviate from the mean. So that's something we'll fill in together as well. Now, the formulas for standard deviation are relatively complex. So I created another table side by side where it's the standard deviation formula for a sample versus that for a population. And so we're going to jot these formulas down, and maybe it doesn't need to be as wide. I do want to leave some space. I'll just leave that as is. So I do want to leave some space. This is something I do to kind of highlight the icon. Scooches. Actually, I'll leave it there. Sorry, I'm kind of varying myself. So I do want to leave some space where we can annotate and point out that the letter N that I use is different for each of these. So lowercase n for the sample and uppercase N for the population, and there's a slight modification. So I do want to do a side-by-side comparison and leave myself some room to point out the different elements that differ between the two. So to build on the data set from page 1, we're going to move on to find the standard deviation of the same data set. And if you've ever done one of these by hand, there can be quite a few steps. And so I think that would be something that you might want to scaffold like I'm doing here. One of the important steps is to find the mean, the sample mean. And I have this in bold notation just so that it pops out a little more. It can kind of get lost when it's not bold. So I just want to point that out. As a linear algebra instructor, we would interpret that as a vector. So just be careful about that. So that's just more for aesthetics. So we're going to do a quick calculation for the mean. And I kind of left myself some space here to do it by hand, but it might not be a bad idea to get some practice with using the graphing calculator to find the mean as well. And then I have a table, and that's part of my step 2, complete the following table. So in this first column, we're going to list out all the individual sample values, and then we're going to see how much they differ from the mean, which is a critical step in the formula for standard deviation. And then, as you might be aware, you have to, I'll probably fix that bar that's above the x. You have to take those differences and square those results. But you're not finished after you do that, because you then have to add the entries in the final column, then divide by n minus 1. So in this case, that's going to be 8. And then apply the square root. And here's a little note about rounding. So the author, and this is good practice and good advice, the author recommends that you round to one more decimal place than what's actually present in the data values. So if we go back to the data, each one of these is rounded to one decimal place or the nearest tenth. So we're going to have to round our answers to the nearest hundredth if we can. So that's a lot to go into just a one calculation. So what I might do from here is I might break off and show them how they can find the standard deviation using the graphing calculator. Which, by the way, if you find the mean using your graphing calculator, you'll have the standard deviation for the sample anyway. So it might not take up too much time. Just refer back to the results for this and show them which standard deviation to use. So the third and final variation measure in this section is variance. And one thing to note about variance is that variance is not necessarily the same as variation itself. So I'm going to have to think about a creative way for students to remember that little nuance. But I have the definition for it as well as the corresponding notations. This is essentially the square of the standard deviation. And because the standard deviation is a sensitive statistic, I'm not sure if I mentioned that. Yes, I did. Okay, so yeah. Because the standard deviation is sensitive, so is the variance. And I just left us some space to essentially copy down the results after step 4 is completed. So then this phases us to kind of like the last leg of the notes, the range rule of thumb, also known as the range of usual values. This is one of my favorite things in statistics, by the way. So this is a graphic I took from the textbook, and it says the following rule of thumb, perhaps I should put that in quotations, is based on the population mean sigma and population mean mu and population standard deviation sigma, the real sigmas. Okay, so if you've encountered this before, the range of usual values tells you the values that are most likely to happen and those that are highly unlikely to happen. Or stated differently, either a value that's significantly low or a value that's significantly high. And you kind of center things at the mean, which is no surprise, and you subtract twice the standard deviation to get a threshold for significantly low values, and then you add 2 times the standard deviation for the threshold for significantly high values. And it says the above diagram tells us a few important things, and these are items we're going to fill out. For most data sets, the majority of sample values lie within 2 standard deviations of the mean. All right, so it's important to point out that there's a 2 in front of sigma. Having taught this course online for such a long time, the 2 can be missed more often than you might anticipate. Values are considered significantly low or unusually low if they are mu minus 2 sigma or lower. So I'm basically pointing out the left portion of this diagram and also the right portion of it right afterwards. Values are considered significantly high or unusually high if they are mu plus 2 sigma or higher. And it might feel a little choppy here, which if I can find a way to finesse this a little more, I will. But this is kind of the route my brain took. In the textbook, there's also a range rule of thumb for an approximation of the standard deviation, and that would be sample standard deviation. And this might be new notation for them at this point in the notes if you use these, which I'm okay with including that here because it's a teachable moment. You can let them know that SD stands for standard deviation. Not a big surprise there. But it's basically the range divided by 4. So what I might do is I might go back to the range value from the first page divided by 4 and then compare it to the actual standard deviation that we found on page 2. And this is a segue into the empirical rule for data with the bell-shaped distribution. And this is a concept that is helpful in interpreting the value of a standard deviation is known as the empirical rule. And it states that for data sets having a distribution that is approximately bell-shaped, so make sure you emphasize that. Maybe I'll bold it and italicize it. The following diagram applies. And this is a diagram from our textbook, and this basically tells you an approximate amount of the population falling within a certain number of standard deviations. All right, so kind of working inside out, 68% of data values will usually reside within 1 standard deviation of the mean, whereas 95% are within 2, and then almost 100%, but not quite, 99.7% are within 3 standard deviations of the mean. And let's see, something that I'm missing here, which we'll do this live. I'll insert a table. Give ourselves some room to write. I'm going to write justify this. So I want it over here. Over here. I'll just kind of hit the delete button. I want this row to be like so. And to stretch it out just a little bit. Maybe that was too much. All right, we'll see when I type it out. I prefer to have thicker borders on these tables. It's easier for copy purposes. So you can go up here to where it says Table Design, and this drop-down menu, select 1.5. That's my default go-to. And then over here, it should say borders. You can click the down arrow and then select all borders, and it just automatically makes them the thickness that you want. I'm going to highlight these 3 cells and go to table layout and do that for the header. And I'll say always, or I'll say remember these phrases. Homa, 10, and bold. Scooch this over a little bit, a little smaller. Yeah, I think I'm okay with that. I'll bring it up a little higher. There we go. All right, I'm going to go back to these 2 cells, highlight them, and go to table design, actually table layout, and I'll select that one. And I'll say, well, actually, you know what? Let me do this header here. All right, so this is something that I learned from one of my mentors, my linear algebra mentor. So I'll put blank within blank, and I'll copy and paste this. And maybe I'll put quotations in there. Okay, and the phrases are as follows. 68 within 1, 95 within 2. That simple. Okay? And believe it or not, if it stuck with me, it should probably stick with students. So shout out to Professor Schwartz. Great friend of mine. All right, so this is the final page of this note packet. I'm incessantly clicking the save button. For some reason, I'm not trusting Word right now. But at any rate, so facial recognition. All right, so I had Claude. I gave Claude a prompt to conjure up some data related to the topics of this section as well as facial recognition. And of course, did its best. And it came up with some options for me. Option 1 was real data, FBI facial recognition accuracy rates by demographic group. And I almost went with this one, but Claude was saying it was a little too spicy, and I said, I'm okay with handling a spicy example, but I still wanted to see if it had maybe some alternatives, which, I still might do this perhaps as like a review problem, but we'll just kind of I'll have to take the temperature of the class. Because, as a statistics professor, you don't want to shy away from statistics that have some good, teaching points to it. I mean, if you think a statistician has got to see statistics on virtually anything, whether it's considered, non-spicy or spicy. I mean, the math is the math. It's completely objective. And, you want to be informed about all things if possible, regardless of what it might stir up politically. I mean, you have to know what you need to know. I'll put that on a t-shirt. Okay, another one was response time data and then confidence scores. Long story short, I ended up having it give me some data on accuracy across age groups, which is a non-spicy example. And that's okay because the trade-off is this. Like, I think this is more relevant to students because of, this might sound stupid, but, changes in beauty standards, looks maxing, Face ID on the iPhone. There are lots of interesting applications. And also too, this is a story that happened here. If you have a kid that wants to chat on Roblox, let's say, you have to do some age verification, and basically the facial recognition software that Roblox has will take some pictures of you and try to estimate your age. So I mean, this is really relevant stuff, and I think that's actually what put me over the hill in terms of deciding to go with this versus the other one. So it gave me this table of data, and so I kind of vetted it out. And this is interesting. It said why older faces are harder to recognize. So I went and I just basically copy and pasted some of this stuff, but then I forgot to vet this data, and eventually, see if I can find it here. My prompt. Oh, here it is. If you could write an individual one for the backup example, that would be preferred. Also, is the data set valid? And it admitted I should be transparent with you here. The demographic data set is grounded in this. These are approximations by the study's findings. I'm okay with all that, but it gave me the option to source the real numbers. And I was like, oh, sure, why not? And so I told it to source the real numbers. And it says, I want to be fully transparent with you before proceeding. Here's what the research confirmed. So the trend that it observed the first go around with this data set said that the FNMR gets higher with age, meaning that the facial recognition software makes more errors the older people get. However, it says here younger faces have higher FNMR, declining as age increases. So this is based on the real data. And I was like, oh, what the hell, man? I put, didn't the made up data set include the opposite trend in FNMR? He said, yes, exactly right. The original blah, blah, blah. And, I kind of poked at it. I said, that's true irony right there. You're experiencing an FNMR thingy too. So long story short, I rolled with this and I blended it into an example using the range rule of thumb. So kind of show you the data here. I asked it to give me some background information. In 2019, the NIST published the face recognition vendor test, part 3. I might link the actual article itself, which you want to check your article to make sure that the article exists because of hallucinations that AI can do. So I copied and pasted the link that it referred to in its findings, and this article actually does exist. I didn't read through all of it, but I'm fairly confident that I could find the data values in here. So there's a level of trust that I have with it at this point. So really cool stuff. I might reference this in the notes or give them a QR code to scan that takes them to this for further reading. But this is a pretty substantial amount of text here, and I actually wanted to keep it in there because when you're doing real life stats and you have to read studies that are quite lengthy. I mean, some of the abstracts are significantly larger than this, and you have to read through that in order to get as honest of a statistical analysis as possible. So I figured if I leave this in here, it'll kind of emulate real life stuff that they have to do, which is read. Okay, so I included this all. I included all this in here. I tweaked it just a tiny bit. I have a graphic here, and I think right here is where I'll place the QR code. I just have to have my wife make that for me. But I use the honest FNMR percentages corresponding to these age groups, and as you can see, the percent goes down the older the people get. But I put use the range rule of thumb to identify the limits separating values as significantly low or significantly high. And we have all of the measurements needed in order to do this. And I think I just have to get rid of all. This is from the previous section. I'll just highlight that and press delete. There's one last thing that I'm considering putting in here. It's the thresholds of acceptable facial recognition software FNMR percentages in order for a company to trust it and use it. And the thresholds are pretty interesting, and it'd be interesting to take our answer here and see, what level of accuracy is good enough to use this, facial recognition software for. So, for example, is this accurate enough to be used for Face ID on iPhone? Is this accurate enough to deploy at the border for border patrol reasons? And so that there's a lot of good dialogue you can get out of that as well. And yeah, so that is it for this video. Thanks for hanging in there. If you have any questions about any of this or want the guided notes, feel free to let me know. Otherwise, I'll see you in the next video, and stay awesome, Stat Cats. Let's keep bossing up.